Greetings, Dave, WB1 something or other. I want to talk to you about a repair that I recently made to an ICOM IC-746. This is a nice old ham radio transceiver. A friend of mine bought it used, and it's been working nicely, but the dial stopped working. And if you know anything about ham radio, you know that the dial on these things is one of the central focuses of the radio. You spend a lot of time with your finger in the little hole in the tuning knob and spinning it back and forth, and it should be nice and smooth and accurate. But this dial stopped working. It would hesitate and it would stall and sometimes work, sometimes not. And it turned out to be the shaft encoder, also known as a rotary encoder, that's inside the radio, which generates signals that the microprocessor reads to figure out how fast and which direction you're turning the tuning dial. So I'm going to talk a little bit about that and a little more about how it works as we go on. But these parts are not easy to find or get. They're expensive. So we want to try to fix it. All right, I hope you enjoy the video. 7-3, we'll talk to you later. So as we can see here, my friend Kent is spinning the knob on his radio, and the radio is just not responding properly. The shaft encoder is generating erroneous signals, and the microprocessor doesn't know what to do with it. The part number is RMS20-250-201-1P. And it turns out that you can find these parts. I looked it up. I found it on DigiKey. It's available for about $54. So if you want to go that route. Except for one thing, there was one online resource that indicated the shaft length that ICOM used is longer than what the data sheet is saying, than the standard part. And I believe that because when I was holding it in my hand, it felt longer than the 23.5 millimeters indicated on the data sheet. I wish I had a picture of that, but I didn't really know I was going to make a YouTube video out of this until after the repair was done. I've got the data sheet up there on the screen for now, but I'll put a link below, and you can certainly find it on the web fairly easily. So the first thing we did was open up the radio and probe the connector where the main dial comes into the logic board. And I could grab a hold of the A and the B signals, and I could see that one signal was coming out fine, a nice square wave, and the other was just a constant DC level. So that was the B signal, and clearly it wasn't working. So this explains why the dial's not working. So the next thing was to take the shaft encoder out of the radio so I could test it on the bench. Once the shaft encoder was out, we needed a way to probe it on the bench. So I made up a little test board, sort of a test fixture, so that I could apply power to the shaft encoder and probe both the A and the B signals with my oscilloscope. This worked out really well. It turned out to be very handy. We could spin the shaft of the shaft encoder and watch the waveforms on the scope. So the way these things work is by rotating a magnetic wheel under Hall effect sensors. And Hall effect sensors are chips that sense magnetic fields. I don't know exactly what the configuration of the wheel and the sensors are, but I imagine something like the wheel having some sort of vanes that rotate under a couple of sensors, and that's how I drew it here. I'm thinking that the magnetic poles are somehow serrated and divided into pulses that the sensors can pick up. In any case, the output from the Hall effect sensors is fed into a pair of comparators. Comparator is a small IC chip that compares one signal against another. And one of the signals is a steady DC voltage that you set with a trim pot. The other is the signal from the Hall effect sensors. And the idea is to square up that waveform and turn it into a digital signal so that the microprocessor can read it. Now it's real important that that reference signal or threshold voltage is stable and clean going into the comparator. The problem here is that the threshold voltage for the B signal is not. And it's just the comparator can't properly convert the analog signal into a nice clean square wave. So let's see if we can figure out why that B channel might have an unstable reference voltage. Let's start by looking inside this thing. The metal enclosure is held on by 3 metal tabs that crimp over the inner mechanism and the circuit. These can be carefully pried open with a jeweler's screwdriver and then the housing gently pried off. Sorry I don't have a close-up photo of that. It's a bit of a hairy operation, but you can do it if you're mechanically inclined. When you open this thing up, you can see a little circuit board in there. And the first thing that strikes me are the 2 little 4mm square surface mount potentiometers. These set the threshold voltage that the comparator uses to square up the waveform from the Hall effect sensors. These can become unstable over time, perhaps some oil migrated in from the grease on the shaft. I don't know exactly, but it seems pretty obvious that this would be the first place to start. But before I started messing with those things, I wanted to get a little better idea of their initial positions. I was able to carefully get the tip of my scope probe on the center contact of those potentiometers and measure what the wiper voltage was when they're operating. And the one on the A side was about 2.5 volts. The one on the B side was closer to 4.7 volts or some such. And that just seems way out of bounds. 2.5 volts is mid-range in the supply. That seems about reasonable. Now that I had a starting point, I could go in there and tweak the B pot, VR2, on the circuit board. So I did that. I did it when I was rotating the shaft encoder. Actually, I had Kent do it. He was rotating the shaft encoder, and I was in there very carefully with my oscilloscope, watching the B signal as I gently touched the potentiometer VR2. And what do you know? All of a sudden, the signal came back. It started coming back, and the B signal started pulsing with a square wave. Sadly, though, the square wave was not 50% duty cycle, and as I adjusted the pot, I couldn't seem to find a place where it was really stable, a nice stable 50% duty cycle. So I'm suspecting that pot is dirty, or there's some oil in it or something like that. It's pretty tiny in there, and really took a steady hand, and you can see I've got the part mounted in a vise. Then I watched that wiper voltage as I turned the trimmer pot, and it was all over the place. It was really noisy and jumpy and just not very stable. Anyway, so finally what I did is I just put a little teeny drop of 99.9% isopropyl alcohol in there. I just dropped one little drop into the B pot and rotated it throughout its entire range. And then as I'm watching that center wiper connection on the scope, I moved it back and forth, and I could see that the reference voltage was now moving nice and smoothly from 0 all the way through 5 volts. So that's just perfect. And then I went through and adjusted it till I saw a 50% duty cycle on that B signal. And I went back and measured it, and that DC voltage was just about 2.7 or something like that. So that seems just perfect. I took a couple of scope shots showing both the A and the B signals after being adjusted. The A signal is in yellow, and the B signal is in magenta. So I'm alternating between a couple of the shots so that you can see the relationship of them when you change the direction that you turn the knob. So from there, we just put the metal backing back onto the shaft encoder. Bending those tabs back over on the enclosure required pressing with a little bigger screwdriver against a hard surface. Maybe a few drops of glue would have been a better idea here. So we put it back in the radio, and what do you know? Everything's fine. The dial's working perfectly, just as it should. So as I say, I wish I had had some video of this, but didn't know I was going to make I was going to document this as a video. So sorry about that, but maybe next time. Anyway, the ICOM IC-746 radio is actually a very nice radio, and Kent is very happy with it, and we're glad to have this repair taken care of. So I hope this is helpful to you, and you can go out and buy the control, but the shaft length apparently is not right. This is an easy repair. Well, I wouldn't say it's an easy repair, but it can be done. And if that fix doesn't last, these little surface mount potentiometers can be had. I don't know what they cost. I'm guessing 50 cents for this part. And if you have a steady hand and a fine soldering station, those parts can be replaced. So good luck, take care, enjoy your IC-746. This is Dave, whatever, signing off, and we'll catch you later. 7-3.